All right, I think we're here. I'm having a little bit of trouble with the camera, the one that shows the printer. So if it freezes, just let me know in the chat and I will reactivate it, because sometimes I don't see that it's actually frozen. We won't need it all the time. Actually, we may not need it much at all today, but if I'm showing you something on the screen and it doesn't actually show up, just let me know and I'll try and fix that. All right, so last time we did some calibration. We did, what, 4 calibrations? We did the PID tuning. We did flow rate. That was the last one. We kind of sped through that one. We might need to look at it a little more. We did, what else did we do? Let me check my notes. I can't remember what they all were. Let's see. Oh, the first, we leveled the bed. That's sort of a calibration, sort of a, you just need that to work. And we did E-steps. So I've had a couple of questions about some of these. For one, on the PID tuning, we did that through the Pronterface terminal, and some people were having trouble. It runs on Python, and maybe you don't have the Python language already running on your computer. You don't want to get all that going. There are other interfaces, terminals. In fact, Cura itself has a terminal. It's just not as robust, but here, this little monitor, this is Cura 4.9.1, I believe it's the version that this is. They all look very similar, unless you go back to version 15, I think is the one that looks different from this. This monitor tab, now mine is not connected, so it's going to be blank, but it will have a way for you to send G-code there. So that's one way you could do that. There's another popular one, Repetier, repetier.com. Will take you to that, and maybe if Pronterface is not working, maybe Repetier will work. Remember, one of the biggest things that cause these to not work is having something like Cura open and your USB cable plugged into your printer, and then the other terminal, Pronterface or whatever, can't access that USB port because Cura is already using it. The PID tuning is probably, of the 4 we did last time, it's the least important anyway. Your printer will print without PID tuning, and you probably won't notice a lot of difference unless you are putting the printer in a very different type of environment than what it was in before. Now, if you change things, so if you go in and put a new nozzle in, put a new heater in, or if you change things about hardware on the printer, particularly related to the hot end, then yes, you do need to do PID tuning. Out of the box and no changes, PID tuning will have a minimal effect unless the environment that you put it in is very different from the environment where it was intended or assumed to be put. So I don't think that one's one that you need to worry about too much if you can't get the terminals to work. It's where you can send G-code directly to your printer. The first layer, obviously, that's important because you can't even print if you don't get the first layer right. There were a couple of comments in the Discord about print sticking, like you print it and you just can't get it off of the bed. Looks like the camera is frozen right now, but we don't need to see it. I think I can react. Yeah, it's relatively easy to reactivate, but the bed itself, some old prints on there, something sticking down to the point that, how are you going to get the thing off of there? There's a couple of things. One thing, let it cool, let the part in, the bed cool down, and that will generally help most of these parts come off. Get a scraper. You get this one in the box. I have this one, which the difference being this one's wider, which that's not the main point. The main point is that it has a much, much sharper edge than what you get here. You could take, if you have a file, you could sharpen this up and get under there a little bit better. That will help. If neither of those work, there are options for if it's possible to remove the print surface, like it has the bed clips and you can remove the print surface, then put that thing in the freezer for 10 minutes and let it get really cold, and sometimes that will pop it off of there. The reason that they're sticking usually is that you've printed too close to the bed. So for the next print, once you get that one off, the next print, raise your nozzle a fraction of a millimeter higher. That either means turning all the bed screws so that the bed is a little lower. You could try adjusting your limit switch to where it's a tiny bit higher. It's very difficult to do. Some printers do have thumb screw adjustments that will raise and lower this, and there are prints that will add that to your printer, so you can find people who have taken this hardware and printed a new mount for it that allows it to be finely tuned up and down with a thumb screw, so that you can get that offset more predictable. But those are things that you can do if the prints are just stuck to the bed and you can't get them off. The other thing that does cost money is change the bed surface. We'll do that eventually. I have a different bed surface. I don't remember which one I actually got, but typically the ones that I get are a PEI surface, so that the way this material works is when you heat it up, it bonds with the PLA or the ABS or most materials that you print on it. It bonds with them and holds on to it until it cools back down, and then the parts almost slide off of there. So there are different print surfaces. The Creality glass bed has those dots on it. Those are similar, just a pattern of PEI dots on the surface. I believe they're PEI or material like it, and it will actually grab the part and hold on to it. Two cheaper alternatives to replacing the whole bed are to print on blue painter's tape. So I get the wide, I don't have a piece of it out here right now, but I get the wider, 3-inch blue painter's tape and put that on the bed and then print on top of that. And that will serve as a little bit of a release agent. Another one that's I don't like as much because it's kind of messy, but it can be cleaned up really easy. It's just glue stick. So I do have one. Just glue stick directly on the bed. I usually do that when the bed is in its heating phase, so before you started printing, but the bed is already heated up. I usually put some glue stick in the area where it's going to lay down the print, and that glue stick will help release the print also. It does clean up with water. These are just regular PVA glue sticks, nothing special, and so you can get it off of there, and one coat will last for multiple prints. So those are different things that you could do to you bought a glass bed for the Ender 3. Yes, that will work well. That I have one. This printer did not come with one because this is like the cheapest Ender 3 you can get. There went the video freezing. I noticed it that time. So I haven't put it on here yet. Throughout the next 9 weeks of this course, I'll add various upgrades, and one of them will be different beds. The beds are generally the easiest thing to upgrade because most of them, you take the old bed off and you put the new one on top of it. Some of them are magnetic, and so they will require you to stick down a magnet. But other than that, it's pretty easy to upgrade or change the bed. But yeah, the Creality or a glass bed, you can even, the very first print, I still forgot to get the first printer. It's not in this room, so I can't go get it easily. The very first printer I printed on, it literally had a sheet of glass from a window store. So a glass store, I asked them to cut me a sheet of glass. I think it was 8 inches by 8 inches at that time was the size of that bed. And so it was a window pane piece of glass. And I printed on that for a long time. So just regular glass will work. And you have the benefit of once you get the glass clean, here's my bottle of IPA that I spray on there. But whatever surface you're using on periodically, take it off if it's possible. Most of them can be removed these days anyway. Take it off of there and hot, warm, soapy water, wash it down, dry it really good, clean it with alcohol cleaner like isopropyl alcohol, and then don't touch it. Don't touch it at all for as much as you can. And if you get the distance between the nozzle and the bed correct, so that you're laying down a very good first layer, almost all materials will stick to glass, pure just glass. You can get a picture from Walmart and cut the picture frame out, put that frame, the glass on here, and print on it. Just be careful, because most of the time when you yourself cut it with one of those glass cutters, it's going to have a little bit sharp edge. You can sand glass, with some sandpaper. You can sand that edge down a little bit. So those are some things that will help you get the parts off, and help. Some of those are designed to help stick. Other people use the really cheap hairspray as a surface. I would do that if I had a glass bed, not on something like this. I don't think it would really help on something like this. This is a decent bed. So this one is not the magnetic kind. The magnetic kind that comes with these, the kind of floppy one, I always have trouble with those, because inevitably I will be trying to remove a part and I'll gouge that softer material, or usually what happens is I don't get the nozzle the right height, and I draw basically lines into the bed, and it deforms it permanently with the hot nozzle, and it's got these little grooves in it. But this one's one of the rigid ones that's put on fiberglass, and so this one you can flex a little bit and pop parts off of it. So it's not a bad bed. It's holding up okay. I've only printed a few things, but you can kind of see, something, one of those little calibration corners is kind of still stuck there. But all of these beds, if you will keep them clean, like I've been touching all over this one, so I'm probably going to have trouble printing on it next time. So those are a couple of tips for the first layer. The E-steps I didn't get a lot of comments about. That's the one thing, other than leveling the bed, that's the one of these that probably is the easiest to do. I may not have shown it the easiest way, because I did go through the terminal, but for most printers, you can change it directly on your control panel. And in this one, I don't have the printer on, so I got to boot it up. But in this one, if you go to control is the option, and then motion, and I have steps per millimeter, I can change X, Y, Z, and E steps on the screen right here. You just have to remember to store the settings. So in the screen before this one, there is store settings. So once you change them to whatever you need them to be, do your calibration, then you store them here. So you don't need the terminal to change the E-steps, and it's probably the one that will have the greatest effect on making your prints a little more accurate. And then we did the flow calibration. We did run through that one because I remember our calculated flow rate was something like 87%. I did drop it down to 90% and print, and that seemed to be a little bit under still, like the lines were a little too thin. So I'd probably in practice run it somewhere 93, 95%. I haven't printed enough parts on it yet. I did print these orange ones. These are orange ones that I've printed. These are for the other class that I teach. You might recognize what they will do later on if you're in engineering 2. Well, you wouldn't be in engineering 220, but you took it at one point. So they're going to be for that. And this printer printed those, no problems. One tiny problem. So remember, my bed is not very flat. It's kind of bowed upwards in the middle like a dome, and this part sitting this way peeled a little bit. Well, actually it was sitting this way. I can see the peel. It peeled this corner. Oh, it froze. So it peeled this corner up a tiny bit. So a couple of things you can do to keep parts from peeling up. I will talk about a brim that you can add in Cura or your slicer, whatever slicer you're using. You can add a brim. And don't be afraid if you see a part begin to fail. You can go in and tape it back down to your bed as it's printing. Maybe you have to pause the print to get it on there, but you can pause it through the control panel on the printer and tape the part back down if you don't want to start over. A lot of times you've already invested, 30 or so minutes, and you think you can save the print. Now this one, it saved itself. It didn't actually fail, but this corner back here is slightly raised up. So that means what was happening was this side of the bed was just a little bit lower than over here, and it didn't stick as well. Now I print this part this way. For tall parts that are shaped, anything similar to this, it would actually be better to print it this way, because and I didn't, and it was fine, but this bed moves back and forth, right? And so for parts that are shaped like this, that moving back and forth is going to make it want to do something like that. And if it doesn't fall completely over, it's at least going to vibrate near the top. The taller this thing gets, then the more it's going to shake back and forth as it moves on the bed. And if you print it this way on that same bed, it's sliding because it's not stuck, but it's not going to vibrate at the top nearly as much. So when you might think about the shape of the part and the motion of the printer, how it's going to move around, and you can get better prints by printing things in different orientations. This is not going to affect this one, but here, if you had a part that was very skinny, so much skinnier than this, like came to a peak, like a pyramid at the top, then there's a really good chance that that top part is going to be all deformed, because the printer, when it's printing those very top layers, if it's just a peak, it's just going to make a little circle, then move up, print a little circle, move up, and the hot nozzle never gets very far away from the material underneath it to let it cool down. And so the tops of really spiky things tend to be kind of deformed. A couple of ways you can fix that. One of them is just print two of the things. So, print them, two of them, and so when it's over here, it prints, and then it has to move over to the other one and print, and this one gets to cool down while this one's working. Then it has to move over here, and this one gets to cool down while it's working on the orange one. And so you can print two things, two copies of the thing, and it will produce better peaks at the very tops of stuff if you're having that trouble. It's a cooling issue for PLA, so the little cooling fan is not able to cool the parts well enough. Another thing you can do is you don't want to print two of them. You could just print a sacrificial thing, so literally just a column over to the side that you don't want at all, but it's it's the thin column that makes the print head move away. Would it not be good to print that first? So that's a good point. Printing it this way, yes, this would probably be a better orientation to print it. Why I didn't do that is I was mounting magnets in here, and I wanted these to be perfect circles. They would have probably been fine this way, and so instead of this would have been a perfect circle laying down this way. Instead, it's made up of all these little layers, but I was trying to save these perfect circles, so I could insert those magnets without having to glue them, just insert them with a press fit, and it worked that way. So yes, if I didn't have the goal of keeping these perfect circles on the top, then this would have been a much better way to print these parts. They wouldn't have had any problem as far as wanting to vibrate around or anything like that. So this would have been a better orientation, but for the one reason of wanting to keep these perfect circles on the top, that's why I printed it standing up. So all sorts of things like that will affect your print. Then we did the flow rate, and today what I want to do is talk through the slicer. So let me turn this off. We don't need it on probably at all, and it's just kind of making noise. That's not the slicer. Where's the slicer? There's the slicer. So this is Cura 4.9.1, I believe, is the current version that I'm using. Yes, 4.9.1. But this is what we're going to talk about today applies to any slicer, whether it's Cura or Prusa or any of the others, Idea Maker, whatever. All of these are the most fundamental things that you will want to worry with. I'll show you how to use Cura just because it is one of the most frequently used. Prusa slicer is probably gaining, maybe it has gained in past Cura, I don't know. It is a really good slicer, but I'm pretty sure that Cura still has the largest user base. So the first thing you have to do is add a printer in to even work with. You can find, well, I don't need that. You can find all sorts of printer profiles online. Remember I said that every printer seems to have a really active Facebook group. They will all have printer profiles that you can import. Cura, for the most part, has, if you go to this little tab over here, if this tab isn't here, you might have accidentally clicked Preview or Monitor. So you want to be in the Prepare tab to be able to see where your printers are. Manage Printers or Add Printer. And Cura has almost any printer you're going to be able to think of unless you custom built it. And there are, you know, obviously some printers that aren't in here, but this covers a lot of different printers. Even has the Voron printers in here, which are pretty custom hand-built printers. So certainly the base things, the ANETs and the Crealities and the TiVos, they're in here. And so you go pick out the one that you have, and that will get all of the default settings pretty much right for most any printer you're going to find. I named mine Summer 2021 because I have 4 printers in here, and I just wanted to make sure I was using the one that we actually were working on. So the main, let's see what I have, 1, 2, 3, I have 6 slicer settings. There are hundreds of slicer settings. Now we're going to talk about 6 of them, and we'll scatter the others in as we move through the course, but these are the 6 that make the most sense to start with as far as things you might want to change. So, or at least know what they do. Layer height is the very first one. What this does is, remember, the point of the slicer is to take your 3D geometry and to slice it into layers for your printer to print. In general, your printers that you're going to have start out with a 0.4 millimeter nozzle. So the nozzle, well, it's not on the screen, but the nozzle in the where the filament comes out down here has a hole in it that's 0.4 millimeters. Unless you have changed something, then that's true. And what that means is that there's a range of layer heights that are going to print well with that nozzle. And the range is typically 25% to 75% of the nozzle diameter. So if you have a 0.4 millimeter nozzle, then you can go down around 0.1 millimeter layers, so pretty thin, up to about 0.3 millimeter thickness layers. So that's about as thick as you can print with that 0.4 millimeter nozzle. The default, now mine is actually changed to 0.28 right now, but the default is 0.2. 0.2 millimeters is kind of the default standard layer thickness. So it gives you a pretty good balance between surface finish of your part and time to completion. Obviously, the thinner the layers are, the more layers that have to be printed, so it takes longer to print. But 0.2 is kind of in that range. I actually print a lot of things like you saw at 0.28. And the 0.28 instead of 0.3, that has to do with the actual stepper motor and lead screw. So the stepper motor and lead screw, oh, it's a little choppy. I think maybe the USB is having an issue. So the pitch of this lead screw and the lead of it, combined with the step resolution of the stepper motor, create what's called magic heights, or these ideal heights. And so your stepper motors, we'll talk a lot more about how they operate later on, but that combination means that 0.28 for this particular printer is one of those preferred heights instead of 0.3. So that's why I use 0.28. And we'll actually go through that later on. It's kind of more of a, side topic than something we want to spend a bunch of time right now talking about. It's certainly not key. You could put any number you wanted between 0.1 and 0.3 and it would print. And you probably wouldn't notice too much difference. So that layer height is one of the main things that you'll want to change. Getting thinner, so dropping down to that 0.1, does mean you have to be more calibrated on like the flow rate because the layers are very thin now. You have to have good cooling. Another thing, I didn't mention this, another thing, if your prints are suffering from not cooling well enough, put a fan that blows across the entire print bed. Now this will affect your hot end also because it's going to be cooled also by that fan. But most hot ends today have a silicone sock around them and they're pretty well shielded from drafts. But that fan blowing across the whole print bed will help cool the parts. And I've had decent success when a part was just too thin or it just wouldn't cool very well, just putting a fan blowing across the print. But what I was saying is when you drop down to those thinner layers, you do have to have good cooling for PLA anyway, good cooling, and your flow rate needs to be calculated pretty well because any under or overflow is going to really show up when the layers are so thin. I'd skip over, well, walls. I wouldn't skip this one. I would know something about it. I don't change it often. Actually, I do change it because of what I'm trying to do. If it's just a part that I want to print quickly, but it doesn't have any actual structural needs, then you can drop the walls down to 1 or 2 walls. These are the walls, the traces around the outside of the part. 2 walls is usually as low as I go. 1 wall does get pretty flexible, but if it's just a part that's not going to do anything, then and you want to print it quickly, then 1 wall will probably work. I currently have it at 3, which is at the lower end of something that you want to have some strength. So you can kind of even see. Let me reactivate the camera. You can kind of, I don't know if it's going to show up very well or not. Let's see if I can get it to focus on that. No, I can't. It's going to focus on everything else. Let's move this out of the way. I think you get the idea of the walls, but just in case, let's just go down there close to it. So yeah, you can see the walls there. So see how there are a couple of straight lines on the outside? Those, for this print, I wanted to have 3. I generally would have done 4, but this is a relatively small print, and walls are slower to print, so every wall you add does add a pretty significant amount of time to the prints. But what I wanted is I wanted to snap these magnets inside here, so I needed some structure around them. So walls aren't only on the outside, they're also around any holes that are in the part. And so I wanted some extra walls around here so that when I put these magnets in, they didn't just fall out. I wanted a little bit of resistance to pressing them in. In fact, here you can kind of tell that one broke a little bit. It broke the support underneath it, and it inset a little bit more than I wanted. But it works fine. So walls, I wouldn't change them much unless you're trying to increase strength. So I'd go up to maybe 4. Or wanted to decrease printing time a little bit and I didn't care about strength, I'd go down to 2, maybe 1. Let's see. The top and bottom, I don't, those, I set them to 4 for the top and bottom layers. So this is the number of solid layers on the top and bottom of your print. Again, 4 is a little bit more for strength. You can get away with 2, probably as the minimum. 2 top layers. What could happen is the top layers don't look as well because it only has 2 solid layers, and it takes a couple of layers to start covering up all the infill. So the infill is not solid on the inside of these parts. I assume you've printed something and seen, kind of in the process of printing that the inside is not solid, and so the top layers have to bridge across all of that infill. And so with only 2 top layers, that very top one, the second one, may not print very smoothly. So 3 is probably your minimum top layer for smooth top prints. Obviously the bottom one is going to be on the bed, so you can have just one bottom layer if you don't need the strength down there. I usually do at least 2. I did 4 on both of these for strength purposes. Infill, I generally print at 15 or 20% infill. So this is a relatively solid, but not at all solid, but it's relatively structurally sound. It doesn't, you know, flex too bad. You can go with 0 infill, and obviously the parts are going to just have the perimeters. Sometimes you want that, but in general, no. Unless you're just trying to save time, or you know that the infill is not needed for your part. But 15 to 20% is about where I print most things. If you want to print a solid, like you want something really, truly solid and strong, don't run this up to 100. What I do is I change the number of top layers to something like, you know, 10,000 or something ridiculous, so that every layer is a top layer. And that will, to me, that's a better approach than just making the infill 100%. Once you get the infill to about 80% or so, it doesn't really add any more filament to go up to 100%. And infill prints faster. Look at the infill speed is 50 versus top speed is 25. So it prints kind of fast, and you know, it's not as accurate. So if you want an actual strong part and it's not a very large part, then just increase your number of top layers to 1,000 or more than you have layers in your part, and that will make a strong part, and it's actually pretty solid. Again, it's going to slow the print down a lot, so don't do it on very large parts unless you have a long time to wait. The printing temperature, obviously that is going to affect how well your part comes out. So for PLA, I'd usually print around 200. The hotter you can print, the better the layers will stick to one another. So you'll get better interlayer adhesion. In general, the cooler you can print, the better the surface finish on the outside is going to look, because there's not as many chances for drips and sags and runs and not runs, I'm thinking of paint right there, but for, you know, blobs on the outside, and strings and things like that, because the material is not as hot and it can cool faster. So lower temperature generally gives you a better surface finish. Higher temperature generally gives you better interlayer adhesion. And I usually sit to the middle or a little bit to the hot side, because I haven't noticed a lot of bad surfaces. Now in these prints, let's see if we can see them. Hey, camera's still going. These prints, they do have, you can kind of see, when I turn the light on, you can kind of see some uneven layers in there. And I probably could even those out a little bit better if I, that one really shows up, if I printed a little bit cooler. There appear to be patterns in this, you know, kind of a striation. So it could be steel. Remember, I did this little hack fix of putting some cardboard in here, so I could still have some misalignment in this lead screw. I'll work on that, you know, try to align it better. There were some, in the Discord, there were some suggestions on how to align that, and I'll have to see if any of those will work for my printer, versus just shimming it out. There's my little shims in there. All right, go back to the slicer. Oh, I don't know where that came from. Adhesion. This one in Cura is called build plate adhesion. There are 4 options. Well, one of them is none. So there's 3 options plus none. And each of them has their own purpose. On these parts that I just showed you over here, can't figure out where the camera is at. These parts, I used the brim as the build plate adhesion type. So what this does, let's bring a part in here and slice them so you can see the different, what they do. What is this? That's just a cylinder. That's that. Well, let's use this. All right. So this is the pin for our pin joints that we were printing. So the brim, when I slice it, when you slice something, always preview what it's actually going to do. So click on preview, and this little blue or cyan circles at the bottom, that is the brim. So it actually connects to the part, and then it, it gives a little bit more surface area to stick that part down to the bed. So if you have parts that you think they don't have enough surface area, so they're tiny, or they are prone to wobbling or whatever, then this brim can help with that. The skirt doesn't have anything to do with attaching the part to the bed. What it does is it actually prints a ring, or it traces a silhouette around, here they are, around the part. So what I do with this, if I'm not concerned that the part's going to fall off of the bed during printing, or it's not going to warp or anything like that, then I still do a skirt, because what I can do with this is, as this skirt is printing, I can do some fine tuning to the bed height. So I can turn the knobs on the bottom of the bed to change the level, the height of the bed, where this part is printing, based on watching it print these circles or whatever the perimeters are, before it actually prints the start print. So you can kind of tune your bed level with this skirt. A raft, maybe your bed is just nowhere near level. It's wavy, and you just can't get parts to stick to it, or you have little tiny parts that even the brim won't hold on. The raft is probably what you need at that point. What it does is it actually prints a whole raft, like a little platform, for the part that you want to print. It prints this platform on top of your bed, and then your part prints on top of the platform or the raft. So this is good if your bed is wavy, because then all the waves are kind of absorbed in the raft. So the bottom of the raft may look very bad, but the top of it should be pretty flat. Now it does add, let's see, 2 hours and 9 minutes with a raft. With a skirt, we were at, well, this one didn't add a whole lot. It added, 10 minutes ish to the print time. So that's not a lot to sacrifice, but some prints, adding a raft does add, half an hour or so, maybe more, to get it printed. But it's kind of a last resort. You just can't get things to stick. Your bed is too uneven, parts are falling off of it or whatever, then you might try a raft. I generally don't print on rafts, except for one little printer I have over here that it's a different style printer, and I do print on rafts on it pretty much all the time, just because of the way it operates. But a raft is kind of the last thing I try if I'm having problems getting the print to stick. Like I said, this is not even all of the options. All of these, so like quality, have this little settings cog. And if you click on that, you can turn on all sorts of additional options for everything. So there are hundreds of different options that you can add. This is for Cura, that you can add in to get exactly what you want to happen on your print. Usually Cura also has experimental, and these are well, there's nothing in there right now. Maybe all the experimental ones have been either chucked out or approved. Let's see make sure there's nothing. Yeah, it doesn't seem to be anything in experimental these days. Well, in the previous versions, you would check experimental and there would be things in there. So apparently everything right now in this version is either in service or it was never going to work, and so they removed it from experimental. Those, how would you move? Oh, how would you remove a raft from the print? Yeah, that's a good question. In general, if you are going to use a raft, the settings for raft are correct already, but this raft air gap, I have mine set to 0.3 millimeters. That's the distance between the raft and the the part that's going to be printed on it. And so if you're having trouble removing it, then you have to increase this air gap. Typically, they just peel right off. Most of the time, they're set to where it peels off very easily. But if you are having trouble, I would test it out on a much smaller part first. Print a raft with a little part on top of it and just test how easy it is to pull off of there. And you might adjust this air gap to make it a little bit larger distance between the model and the top of the raft. Or if the model is not sticking, then reduce the air gap. But typically it peels off very easily, unless this air gap is just not set right. So your flow rate and your E-steps, the things that kind of control how much material is coming out of the nozzle, if those aren't tuned very well, you can over extrude, which will kind of negate the effect of this air gap, because you're putting out more filament than it thought it was. And that's when things will really bond together, and you'll have a hard time getting the raft off of there. For the brim, I just use a deburring tool or a knife to cut the brim off of there. If you get the brim just right, it'll just peel off also. But a lot of times I do go back and clean up the very last edge of it with a deburring tool or a knife even. Sometimes I use the edge of my scraper since it's, kind of sharp. Wherever it's at, there it is. Sometimes you just use the edge of that for the brim. And the skirt doesn't connect, so you don't have to remove it at all, except from the bed. All right. Those are the settings that I would start with. And like I said, there are a lot of other settings. But these are the ones I would start, trying to figure out what I wanted for the settings. Do I want parts that are stronger, add more walls, maybe a little bit more infill? Do I want prints that print faster, maybe print thicker layers and not as much infill and only 2 walls, and start figuring out what's good for yours. If you change profile to all, oh, yeah. Oh, that's, okay. Where is mine? Where do I change it to all at? Oh, that's the... I have to see where to change it to all instead of basic, because I don't actually know. Well, we'll look at that, because it would be interesting to see what the experimental ones are in there. Let's just search. Oh, no, I didn't want to check all. If you check all of these, then you will get every possible option in your window over here, and it gets hard to find things. So I'll have to look and see where basic and all are in order to actually change them, so I could see what's in experimental, because right now I don't see anything. Not that that's important, but it would be nice to see what's coming in the future. Let's see, we have enough time. What I wanted to talk about next was a little bit of the other thing here in your Cura, or in okay, the little 3-line thing. Yeah, I don't right there. I'm on custom. Do all. Oh, it's still empty. Huh. Oh well. Maybe there just isn't anything in this particular version that's experimental. All right. Of course, now that everything's, I'm going to have all sorts of things to look at. So, plenty of options to look at now. I'm going to switch it back to basic temporarily. Although there's advanced and expert also. But I wouldn't go dig. So the problem a lot of people run into is they change 5 things at once, and then they can't tell which one of the 5 things actually had the effect that they were looking for. So as you're starting out, you know, just change one or two things at a time. You know, ideally you change one thing at a time, but the prints do take a while to print, so you might not want to change only one thing at a time. Let's look at some G-code. So let me go to prepare, printers. Let's manage printers. And I'm using this printer that we just built, and I'm going to do the machine settings. So what this does is it gives me these, well, first of all, it gives me a couple of things I can change if for some reason my print bed is a bigger or smaller size. You know, I can change those sort of things, but probably don't need to change any of these settings unless you actually do change something. So what I want to look at here is this start G-code. There's also an end G-code. So these codes get embedded in the beginning, at the start, or the end of any of the files that you slice using this printer profile. So let's see what it does first, and then how we might change it if we want to. So this line is not doing anything. This is just a comment. So the semicolon is kind of the end of line, and so this text here is just text comments. So it's just saying that it's for an ender 3. Here, this is an actual G command. These are really small. Let me copy them and look at them somewhere where we can see them larger. Let's see if we got a bigger font. There we go. All right, now you can see them. So there, the semicolon just says that there's nothing on this line except this comment. G92 E0. So G92 is a way to, you know, as you're printing, remember the printer has no real feedback on position. These printers don't know where they are except when they hit a limit switch. They know they're at one of the limits. And so everything is based off of dead reckoning as far as position of the print head in the bed. So G92 can reset those to wherever it currently is. It can make that a 0 position. So what this one is doing is it's saying no matter where the extruder is right now as far as the amount of filament that has passed through it. So it's keeping track of, you know, how much filament has passed through it. It's at now 0. So this probably doesn't actually do anything unless your printer does some other things even before the start G-code. So before the start G-code, Cura is going to go and heat up the nozzle, heat up the bed to whatever temperatures you set in the, you know, the, well, oh, I can't close it, into the slicer. So it's going to have already done that. I don't think it's actually going to have moved any of the extruder, but it's just going to make sure that it's starting at there has been 0 filament extruded. G28, this is a home all axis, so it's going to move home X, home Y, and home Z so that it knows where 000 is for the print head. You could go in, maybe you only want to home one at a time, so you could home G28X would home just the X axis. Y would home just the Y axis. Z would home just the Z. X, Y, and Z would home all 3 of them. Here it's just homing X and Y. There are reasons you might want to do this. In fact, we will do this later on when we add a touch sensor. And we want to home X and Y just on the limit switch. Wow, we got all kinds of dogs barking. But you want to home the Z using the touch sensor. So you want to do it separately. So there are reasons why you might want to have these parameters. We'll just have G28 with no parameters homes everything. What they're doing here is that little line that purges out whatever filament, you know, there's filament trapped in the nozzle from the last time you printed. This set of 5 lines is purging that out. So what this will do is G1 is a move command. So there are 2 basic speeds, G1 and G0, for default to different speeds. G1 is your basic move command. and it tells the way these move commands work are, it's wherever you currently are, move to in a straight line to whatever coordinates are shown in the line here. So it just homed, so the nozzle's at 0, 0, 0. Now move to Z of 2. These are all millimeters, so Z of 2 millimeters. So it's going to go straight up 2 millimeters. F3000 is the feed rate, so how fast to move. So 3000 is actually a pretty fast movement speed, particularly for the Z-axis. So now the nozzle is 2 millimeters above the 0, 0, 0 coordinate. So it's actually at 0, 0.2. Or no, 2, not 0.2. From that point, it's going to do this movement command. So it's going to move over slightly. So it was at x equals 0. It's going to move. Now it doesn't do these sequentially. It does that. Remember, it's at 0, 0, 0. By the time it finishes this move, this is the coordinate it'll be at. X of 0.1, Y of 20, and Z. So it moves down, moves the bed forwards a little bit, and moves the X carriage over a tiny bit, all at the same time, pretty quickly. So F5000 is the feed rate, so it's pretty fast. So it's about to start. The nozzle is sitting not quite in the corner anymore, and it's a little bit, 0.3 millimeters above the bed. Here, they didn't even have to include this number, but they did because it's already at 0.1. So if you don't want to change a coordinate, you don't have to include it, but they did. So 0.1. So the main thing that's happening here, Z is staying the same, X is staying the same, but Y is going from 20 to 200. So the bed is basically moving towards you on these tile printers anyway, 180 millimeters. Also, we've got this parameter on this one. So it's a little bit slower. F is 1500. And we've got a little bit slower speed, a little bit slower speed, and E15. So this is going to extrude. E is for the extruder. It's going to extrude filament while it's doing this movement. So it's going to extrude 15 millimeters of filament as it's making this move. And then it's going to do this line when it gets to the end. Going to do this line, 0.4, so it moves X over a little bit. Y stays the same. Z stays the same, so it just slides over to the side a little bit. And then it draws a similar line, but even more filament. So the first one only extruded 15. This one extruded 30. So it's extruding twice as much filament. It's really trying to purge all the filament out of the nozzle. So all of these are drawing two purge lines on the left side of your print bed. And then here we've reset the extruder again because I don't want these 45 millimeters of filament. I don't want to start out the G-code already have extruding 45 millimeters that aren't part of the file I'm trying to print. They're just purge lines. So it resets the extruder to start counting again at 0. And it moves up a little bit just so it's about to start printing the part, right? So it moves up, and then it moves to this position, 5, 20, X equals 5, Y equals 20, still 0.3 millimeters above the, so it actually moves down a little bit and over. And the next file, the next lines after this would be all the stuff that you sliced. So all of the G-code from the slicer to create the geometry you want to print would appear after this, and it would start printing. So it would first start doing a brim or a skirt or a raft if you did a raft. If you did none of those, it would start immediately trying to move around and print the part that you're trying to do. I would always at least do a skirt just for a lot of times these prints are relatively lengthy and you want a good start for the print. And so I use the skirt as a way to go in there and fine tune the bed level manually while it's printing to make sure I have as good a chance as possible of getting this part to stick down and then also not be too stuck down, too close to the bed. So what I thought we'd do is just for fun, change up our purge line. So we need this, we don't necessarily need this line. I'm going to leave it in there because why not? you should home all the axes before you try to do any kind of movement, because some printers have in their firmware limits that it won't move at all until it's homed. And if they don't have that, then you might crash it into something because the printer doesn't know its position unless it's been homed, and from there on it's counting, you know, I was here, then I moved here, so I must be at this point. Now I'm going to move to that point, you know, and it's all dead reckoning. We'll leave this in just to raise the axis up a little bit so it doesn't scratch the bed when it's moving around. But let's change let's change all of these. So what I want to do is I want it to be a little zigzag pattern. So let me kind of draw out over here what I want. Got to reactivate the camera and aim it down here. Oh wow, it's kind of crazy there. Maybe we won't draw it out because the camera's acting really strange. Maybe that's part of what's going on with the camera. I'll have to check it out because it's kind of weird. All right, so let's not do that. I won't draw it out. I just want to make a little zigzag. So let's say that what I want to do is G1 to make a movement. Currently the nozzle is at the home point. We just homed everything and it's 2 millimeters above because it's at Z of 2. So G1, let's go to, let's move everything off from that corner. So we can use the 0.1. Well, actually, let's start at 10. So we're at 0. Let's go to 10. Remember, the G1 is all straight line movements. Most firmwares can do arcs, like they can move in a curve, but generally your slicer does not take advantage of that. So there are ways that you can force your G-code to have actual arcs built into it versus a bunch of line segments. But we'll cover that when we talk about Octoprint, because it's the way I know to do it. It's a plug into Octoprint. Y25. We need to extrude some filament. This is not very far, so let's just do 2. And let's do it at a feed rate of 1500, same as the other feed rate we did have before. We could put a comment here behind it if we wanted to, but I'm not going to worry with it. G1, now let's go to back over to the 0.1. I don't want to go all the way to x equals 0 because that might be too close to the edge, so I'm leaving a tiny margin. We're going to continue going up. I'm going to go by 25 millimeters each time. And why don't we take these two lines, copy them, and paste them a couple of times. Now, if I don't change these numbers, it's going to go back and forth over the same spots. And I don't want to do that. So X is going to alternate between 0.1 millimeters and 10 millimeters. So it's going to go back and forth between those. And Y is going to continually increase. 25, 50, 75, 100, 125, 150, 175, 200, and I don't need these, I guess I did too many. So this set of lines right here should, if we've typed them all in right, should make this little zigzag pattern for our purge line. Then we could return it. You know, now it's going to be at the back of our print bed. So let's send it over a little bit. We're not extruding here, we're just moving over so I can move fast. I need to move slower while I'm extruding so that filament actually has a chance to come out of the nozzle. And then let's go back to the beginning. So straight down, X11, Y20 is where we started, sort of. Well, we did 25, didn't we? We'll do 25. We're going to have to extrude more filament this time. Let's do the 30 like they did when they extruded theirs, and they were at a feed rate of 1500. Okay, so this should bring the line all the way back. And then it resets the extruder. Everything's flashing. Resets the extruder, moves it. Let's see, move to prevent blob squish. I actually want that to be outside of where I just was, so I'm going to do 15, 30. Now, if you are printing something really large, then this 1530 might be in the way of that, so you have to be careful where you put the thing. We're just kind of doing this for fun, just to kind of see an idea of what can happen here. So I'm going to copy all of this and paste it. So if you don't want to just completely erase the stuff that you had before, go and put semicolons in front of everything so that it just kind of comments them out and you can uncomment it later. And then here's our new stuff. Yep, that's all of our new stuff. All right, and then we can close that and we'll see what happens. So let us slice our deal here, and I will turn on our printer. I'll go ahead and preheat it, and maybe we can see if our interesting purge line actually does anything. You may have to fiddle with the amount of filament to purge on each one. You know, we were doing 2 millimeters per little zigzag. And that may not be enough. We'll just have to see. Let's save this. What was it called? Wow, this is a Tinkercad file, so it's got these weird names on them. Now I'm going over to the printer, which, you may not can see the printer though. I wonder if it has behaved itself yet. No, it is not. Let me turn it completely off and back on, and maybe. May have to get my other camera to check this thing out. Alright, it looks like it's behaving better right now. Let's print from the SD card. It's been heating up. It's actually almost up to temperature. And we'll see. We'll see what happens. So in our start G-code, you'll notice there was no hard-coded in temperature for the bed or the nozzle. Those are coming from the slicer itself. Whenever we put the values in for right here. So you don't really want to hard code those into your start code unless you print the exact same material all the time. So we're almost at printing temperature. Hopefully we will get something to move. It hasn't done the homing. So the first thing it should do was, well, the very first thing is reset the extruder, which we can't see that happening. There's the homing routine. So it's doing that part. It was, because it had printed this thing, so it was really far up. So now, well, it's doing the Z part of homing is what it's doing right now. Just a little bit of trash in there. All right, now it should move Z. Well, it's going to finish home. There it moves Z. Oh, all right. Oh, it skipped all of our purge. It just purged here. Why did it skip all of our purging? Oh, I didn't close. Oh, I did a silly mistake. Let's stop. All right, I made a silly mistake. I didn't close all my. Whoops, I want that one. Forgot my semicolons. Actually, that doesn't do anything to it, does it? I need to change it in the printer. I need to change it here. Okay. So that means we'll have to reslice and try again. I'll give it one more chance, because I see our error there. Another thing, if you're having weird stuff happen in your prints, you can read the G-code in Notepad directly. So you can go and look line by line in the actual code that is the printer's reading, and just open it up in Notepad. Actually, a lot of times I use Notepad Plus, just because it's a little easier to read, but this time I was just using plain old Notepad. Alright, so let's get this thing out of the way. It has to do a little bit of heating. It actually has to cool down the bed. The bed actually was hotter than it needed to be for some reason. I think my preheat has the bed heat to 60, and Cura has it set to 50. Alright, let's see if we get a better result this time. No, we did one, and then it stopped. It didn't do all of them. I'll have to check and see what's going on with it. Either that, or I didn't actually print the right file. I'll come back. We're about out of time. I think probably I didn't print the right file. I think I printed the same one that I tried before, which is not what we needed. Well, yeah, we can. I'm looking at the preview of the G-code, and it doesn't show that travel. All right, I think I printed the file that we printed before, but we're out of time. I'll stop this print. I don't need another one of those parts. It is interesting to go in there and modify the G-code. Once I get it set up just right, then we will go in, and I'll post that in the comments for this video so you can actually see what it looks like. I've left off something somewhere, semicolon or whatever, at some point, and I'll find it. I don't want to troubleshoot everything right now, just because that could get boring. But we will dig into G-code here and there, because it is useful for finding things that you know, your machine's doing something that just doesn't make sense, or maybe you've got a particular thing that you want to do, and slicing doesn't do that. It's actually simpler to write the code that you want exactly, or maybe a combination. You've sliced something and then you want particular things to happen during the print. You can go in and edit the G-code, like I said, in Notepad or something similar. It does need to be a text editor that doesn't add things to it. Like, you wouldn't want to open it up into Word and then try to save it, because Word is going to add all kinds of extraneous header information, metadata type stuff to the file, which can mess up the reading of the G-code. Alright, I'm going to work on this and see what went wrong, and see if I can track down our little error, because I don't see it right now. But it's in there somewhere, and I'll find it, and we'll come back to that. Next time, what are we doing next time? Well, I have some more frame, extruder, bed upgrades, a couple of upgrades that you might start with. Again, all of the upgrades I'm going to show are not things you have to do. They're just, here are some things, like the bed some people ask about. I'll show you one that I use, and we'll look at some of those things. Also, I have a list of topics that I plan to talk about. Well, I'll mention this. But if there's something that doesn't show up on the list, or maybe it shows up way at the end of the list, but there's interest in it now, just let me know. Send a message in Discord or an email, or type it in the chat, and I will move things around. This is not set in stone. This is just what I typically do. But if there's a particular topic that you're interested in, let me know, and if enough people are interested, I can add it on. This is a little fun thing you can do in Cura. You can take any model, no matter what it is, and make it fuzzy, or look fuzzy. It's not going to be soft, it'll still be plastic, but it'll make it have a textured fuzzy skin with like one click. This is a minute-long video that I posted a while back that shows you how to do fuzzy skin in Cura. It used to be one of the experimental settings, and now it's in the main set of settings. This is, I did a little Pokemon guy, but it's really good if you're trying to put texture on some kind of grip, like a handlebar or something like that, and you don't want to try and model that texture in there. You can just build a cylinder or whatever your grip shape is, and then add Cura's fuzzy skin, and it makes a really nice textured grip on that surface. So it's a fun thing that Cura just does. Now, it does it everywhere, so you can't really, well, you can't easily select where it's going to happen. You actually can, and maybe we'll talk about that. All right, I will see you guys Wednesday. Thank y'all, and we'll work on our G-code. I'll find the error in it. I'm not sure where it is right now, but we'll find it. And hopefully I can get my camera to not be such a pain. I'll see what's wrong with it. All right, see you guys Wednesday.